Hey everybody, this is review day number 2. Today I am at an ACT conference, so you get this lovely recording to help you out with reviewing the topic for day 2. Day 2 is looking at graphing of both lines and inequalities. Let's look at the slide says when there are 30 girls in a dance, there are 12 boys in the dance. I see that set there of 30 girls and 12 boys. I see that they go together, and I see a coordinate pair. Keep reading. When there are 45 girls in the dance, there are 17 boys in the dance. So I see 2 points there. And then it says assume the relationship is linear, and that means that there is a straight line that is going to go through both of those points. We are going to find which equation models the relationship between the number of girls, x, and number of boys, y. I'm going to go ahead and plot those 2 points. So 30 girls, hopefully you can see this, goes to 12 boys. So I'm going to go to the right on 30, because girls are the x, and up to 12, and that would put me right about there. And then I've got 45 girls. I'm going to go over to 45 and then up to 17. Sorry, this is a small graph. And hopefully you get that right. It's right about there. There you go. So I have these 2 points, and my task is to figure out which equation goes with this line. So I'm going to go ahead and draw just freehand. I don't have line tools right now, so I'm just freehanding this. And the other way. Okay. And so first, possibly the easiest thing to do, especially right now as I'm freehanding this, if I had, a ruler and I was able to actually draw this, I might be able to figure out what the y-intercept is better. But with this, I'm not quite sure, just because I'm going to probably be off, my line isn't straight. I'm going to figure out the slope. So I'm going to figure out the change in the rise there, and then the run between these 2 points. So the rise would be the change in the y values. So I'm going to go y2 minus y1. The y value on the y2 is 17 minus 12. So my y2 is 5. Sorry, my change in y is 5. And then looking at my change in x, I see that it was 30 to 45. So it'd be x2 minus x1. x2 is 45, x1 is 30, that's 15. So again, we find our slope by going rise 5 over run 15. I'm going to go ahead and simplify if I can. That is 1 over 3. Now this is multiple choice. So I want you to look at what I have found the slope to be and look over here. And I want you to go ahead and pick which one is the correct answer. All right, pause there for you to go ahead and answer that question. Looking at our answers, there's only one that actually has a slope of 1/3, and that would be the option C. Now you can also see that if I did extend this line all the way to the y-axis, and knowing that I'm freehanding this, so I might be off a little bit, you can see just by estimating that I'm definitely not hitting at 26. That first laser pointer, that first one would hit at 26. 26 is all the way up here. And then the second equation would hit at 22. That's right here. And this last equation would hit at 9, which is again too high. So I could have estimated or guessed that it would have been this one if I extended my line and saw that it crossed pretty close to 0. Okay, so I'm just going to look at this graph, and you're going to see some questions popping up with this. I just want to kind of explain what's going on here. So you have a graph of savings. So these are their savings account. USD stands for US dollars. And then these are the months down here. The month is actually right above the word. So January, and you can see the rectangle and the, looks like a diamond there, right above January. So these are the January values. And then February, here are the February values. March, right above the word. April, those two. May, those two. And Jack is in blue, or the diamonds. And Barbara is the squares in red. Okay, so again, I want to explain kind of what the graph is looking or what it's saying to us. And then you're going to see some questions popping up. And again, we're just trying to practice what do these graphs mean, interpreting graphs, being able to gather information off the graph. So here we have 3 products represented by blue is product X. That would be this line right here. Represented by the orangish color is product Y. And represented by the purple is product Z. Over here we have the value of the sales. So this is how much money their sales are bringing in. 0. Notice they're going up by 13,000 on each line on the axis. And then again, notice that these are the months down here. This will be the year 2004. January, it's going to be right above the word. It's where you see the little marker. You can see that the product Y, the orange line, has little triangles. Product X has this kind of diamond. And then product Z over here has a square. So February's values for product X would be right here. And for product Y would be right there. Suspiciously, nothing for product Z in February, if you can notice that. So we also want to kind of review how we graph an equation. So the steps, step 1, if you've got it in slope-intercept form, it's probably the easiest form that we could graph in. So step 1 is to mark the intercept. So we find the intercept up in the equation by looking for the number that is not attached to the x. And that would be the +1 right there. So I'm going to go over to the y-axis. I'm going to find +1 on the y-axis. Go ahead and make a dot. Step 2 is to use slope to locate a second point. As I write that up there. Okay. And our slope is going to be the number that it is attached to the x, and that would be the 2 right there. So it's always going to be in a fraction form. If it's not, make it a fraction by putting a 1 underneath it. So 2 would become 2 over 1. If it's positive, you're going to go up and to the right. If it's negative, you're going to go down and to the right. Always to the right, the sign tells you up or down. So being positive here, I'm going to go up 2, to the right 1. So I'm going to start at my dot, at my y-intercept. I'm going to go up 2 over 1, and that puts me right there. And then my third step is to go ahead and connect the dots. And again, freehanding this. Looks something like this. So there I've free-handed graphing an equation, again going through our steps. We marked the intercept, which was +1, that's the y-intercept. We used the slope to locate a second point. The slope was 2. We made it into 2/1. We need it in a fraction form. That means we went up 2/1 to the right, and then we connect the dots and get this equation. Now, way back when, this was, I think, like October, so I know most of you have probably blanked this out. We did graphing inequalities. So it might look a little scary to see this equation, but the starting works the same as graphing just a regular line. So I'm going to locate the y-intercept, which is the +3. I'm going to go to my y-axis and find 3 and make a dot. I go over and I find my slope. Slope is 1/2, conveniently already in a fraction form. The top number tells me up or down. Because it's positive, it's up. And then the bottom number tells me to the right. So I'm going to take 1/2, and that means I'm going to go up 1 to the right 2. So I'm going to go up 1 from my y-intercept and then over to the right 2, and here's my second dot. Now here's where the differences are going to be apparent. You have 4 options. You have this one here, which is less than or equal to. Then you have greater than or equal to. Then you have less than, and then you have greater than. The 2 that are or equal to's, so this one and this one, they get solid lines. Look how straight and flat that was. Oh, darn. There we go. Second one was messed up. Okay, they get solid lines. If you were doing just a less than or a greater than, you graph them with a dashed line. All right, so this one being a less than or equal to, I'm going to go ahead and graph this with a solid line. Trying ever so desperately to make that semi-straight, missing my line tool. There we go. So that's my first part. Second, I need to figure out where to shade them. And this is where the less than or the greater than comes into. Less than, and if you remember this, my way of remembering where we shade is the less than goes below the line and I remember that by remembering that L and L. And then our greater than signs go above. So this would be a less than sign would be below, and a greater than sign would be above. So this is a less than or equal to. That told us a solid line, and that means we're going to shade below it. So that means everything down here, that is some awesome shading. Woohoo, there you go. Everything down here, what this means is the numbers that could satisfy this equation are anything on the solid line or inside of the shading. So any number on the line or in this shading down here, any point, is going to solve or satisfy this equation up here. So for example, find a point that is inside, and let's say we go with 4, -3 right there. If I plug 4 in for x and -3 in for y, I would get a true statement. If I plug in 8, 0, that point right there, 8 for x, 0 for y, I'm going to get a true statement. If I pick anything outside, like maybe up here, let's see, -5, 8, it is not going to work. I plug it in, -5 for x, 8 for y, and I would get a statement that is not true. So that's why we shade with inequalities. It gives us a region or an area of the graph that is going to solve that equation. So this was graphing one equation. Now we have two. This is called a system. So with the system, we do the same steps. We're going to graph one at a time. To the left, y is less than x plus 9. So first I'm going to find my y-intercept, which is 9, and put a dot. Then I'm going to find my slope. Oh no, no number there, right? Well, there is a number there. Every number has a 1 over 1 in front of it. If you can't find a number attached to the x, that means your slope is 1. Take that into 1 over 1, and that means from my y-intercept, I'm going to go up 1 to the right 1. And that is my first 2 points for my first line. Now it's a less than, it's not a or equal to. So that means it would be a dashed line. And so I'm going to attempt, I'm making it a little more dotted. Trying my hardest to dash that line. There we go. So now we get a dashed line for that one. It's a less than, and less thans go below because they both have elves in them. Less than, below. So that means everything below is shaded. I'm going to go ahead and do this with the highlighter. So everything there got shaded. A lot of highlighting on this one. All right, and second equation, I went in green. Okay, so the second equation is going to be in green. We see that the y-intercept is plus 2. So I'm going to go to the graph, y-axis, and put a dot there at 2. And then my slope is 3. Again, if it's a whole number, then you're going to put a 1 underneath it. So 3 is 3 out of 1, or 3 over 1. That means I'm going to go up 3 to the right 1. So starting at the 2, I go 1, 2, 3, up to the right 1. And that would be my second point. Now again, it's a greater than sign, so greater thans still get dashed. So now I'm going to attempt to dash this. Oh my, I got off track there. You get the idea. Okay, it would be much easier with the line tool. Now it's a greater than's. Let's get a green. Above the line, above that line that we just graphed, not the other line, the one that we just graphed is going to get highlighted. Now when you look for where the solution is, so I see 3 regions. There's this region up here, but this region only has the green highlighter. Then I see this region down here, but it only has yellow. I'm looking for the double coated, and that would be this region right here. The highlighter and highlight. Our solution would be this region right here. Now realize this graph is just a small picture. It actually extends infinitely up to the right, to the left, and down. So it's much bigger than what this is indicating, but our solutions are going to exist. So if I picked, for example, -4, -2, which would be this point right here, that's inside of that circled section. That means it's going to solve both equations. If I plug -4 in for x, -2 in for y, into both this equation and this equation, it's going to work in both. If I were to go somewhere, let's say 8, 0 over here, it's going to solve one, but not both. If I were to take, let's see, -8, 5, which would be that point right there, again, it solves one, but not both. You have to be inside this region in order to solve the system. All right, so on this problem instead of being given the inequalities and then asked to graph them, we have been given the graph and we have to give it the inequalities are. So I want you to first start at this solid line right here. We've got two inequalities going on here. So I want to look at that solid one. You're going to see some questions pop up. First one, what is the y-intercept, or where does it cross the y-axis? I want you to look at that same highlighted line, and I want to know, what is the slope? If it's helpful, I'll pick 2 points for you. It doesn't matter what 2 points on this line you pick. If you use those two, you can think of it as, remember we do rise divided by run. So you always go left to right. So narrate the movement from the left point, which would be this one here, to the one on the right. Do you go up or down? And then you go to the right. Now I want you to put those together, and next I want you to type in, what is the equation with or for that solid line? Noting that it is a solid line, what does that tell you about the inequality? And second, if you can't tell, it is shaded below the line. Right here is shaded. That's below this line. Now we're here. So I'm going to highlight the one that we're talking about. And the first question I want you to answer is, where is the y-intercept? Where does it cross the y-axis? Next question, I want to know, what is the slope? With this one, you always want to go for whole numbers. Make your life easier with whole numbers. So I'm going to pick right here. This is a nice whole number. The coordinate pair of this point would be 0, 3. And then I want to scan up and down on this line for where it crosses another whole number on both x and y. So I can see at x equals 2, it doesn't. X equals 1. I just kind of scan down, still not a whole number. If I can see right here, it looks really close, but it's not all the way to the 1. But if I go down here, this location, it crosses at a whole number for both x and y. A little bit of help. The point here would be 1, comma, -1. So we've located 2 points on the graph that are at whole numbers, mostly to make our life easier. If you try to do some of the other points, you're going to be estimating. Stick to whole numbers. What is the slope of this line? Next, we're going to break down into a little bit more. Would this be, it's a dashed line, so is this going to be less than, greater than, or would it be less than or equal to, or greater than or equal to? Next, I noticed that it is shaded below. So what inequality symbol would that be? And your password is ACT. All capitals.